He's a man who understands the true value of time. Soon, he'll begin sending people to Mars, meaning that, at the very least, these explorers will travel 54.5 million kilometers through space. This journey will take at least 5 months, filled with all the dangers that come with space travel. There's nothing he can do about the sheer distance between Earth and the red planet. The only way to shorten the trip is by increasing the speed at which his starship can move. If the spacecraft could travel at the speed of light, most of the problems of interplanetary travel would be solved. However, he believes that would be a terrible idea. But why does Elon Musk think traveling faster than the speed of light is a bad idea? That's exactly what we're going to understand in this video. But before we dive in, make sure to leave a like, subscribe, and turn on the notification bell so you don't miss any new videos here on the channel. Light itself is fascinating and absolutely essential. Without it, watching this video would be impossible. Thanks to the sun and other artificial light sources humans have created, we can move around without bumping into things. But you've probably heard that light travels incredibly fast. So, how fast is light really? Interestingly, the exact speed of light is well known. It's the foundation for many other measurements. Light traveling in a vacuum moves at exactly 299,792,458 meters per second. That means it covers roughly 299,792 kilometers in just 1 second. Light is so fast that if you switch on a lamp in a dark room, the light fills every corner almost instantly. You never even notice it spreading. Another common unit involving light is the light year, which is the distance light travels in 1 year. About 10 trillion kilometers. Astronomers and physicists use it to measure the vast distances across our universe. The universe is so enormous that light can take years to travel from one place to another. For example, the light from the moon reaches our eyes in about 1 second, meaning the moon is 1 light second away. The light from the sun takes around 8 minutes to reach us. The sun is 8 light minutes away. The nearest star system, Alpha Centauri, is about 4.3 light years from us. Other stars and objects beyond our solar system can be billions of light years away. That's why everything astronomers see in the distant universe is literally history. They're looking at light that shows how things looked when it first left those objects. While there are many fascinating things we can do with light, scientists have long tried to find a way to travel at the speed of light, a dream that could finally make humans an interplanetary species. For instance, the billionaire founder of SpaceX wants to build a city on Mars, but his explorers would need to endure at least 5 months of space travel before landing on the red planet. Depending on the alignment of Earth and Mars, the trip could even take close to a year, not to mention the dangerous process of landing itself. However, if we could travel at the speed of light, the same journey would take less than 4 minutes. Researchers have tried many methods to achieve such extreme speeds, but one problem always stands in the way: energy. Even reaching just 1% of the speed of light is extremely difficult. That's fast enough to take you from Miami to New York in less than a second. The challenge can be summed up in one word: energy. Any moving object has kinetic energy, and the faster you go, the more of it you need. Doubling your speed requires 4 times more energy. Tripling it takes 9 times more. For example, accelerating a 50-kilogram person to just 1% of light speed would require 200 trillion joules of energy, roughly the amount 2 million people use in a single day. That's why concepts like the M-Drive attracted so much attention. It was announced as a technology that could take us to the farthest reaches of the universe. Incredibly fast. Theoretically, it works by bouncing microwaves inside a closed chamber, producing thrust without fuel or exhaust. The idea is based on Newton's second law, that force equals the rate of change of momentum. But if true, it would turn physics upside down. How could something move without an external push? Most scientists rejected the M-Drive, and later experiments showed that the tiny thrust NASA and Chinese teams had reported were false positives caused by external interference. Then came a more promising idea: the warp drive. This concept was first introduced by Mexican physicist Miguel Alcubierre in 1994. His idea became the foundation for all warp drive research. The Alcubierre drive, however, required an unimaginable amount of energy and a type of exotic matter that has never been observed in nature, making it purely theoretical. Over time, other scientists refined the idea. Former NASA engineer Harold White proposed an updated version that reduced the required energy significantly, but still needed exotic matter. More recently, a group from the Advanced Propulsion Physics Laboratory in Switzerland presented a new concept that didn't require exotic matter at all. But their model couldn't exceed light speed either. Dr. Eric Lentz, a physicist with over a decade of experience, took things further. Building on the work of Alcubierre and others, he created his own version of a warp drive rooted in classical physics. His model used only conventional matter, and showed that expansion and contraction of space, once thought essential to warp travel, might not actually be necessary. This was a major breakthrough. It meant that, theoretically, we might not need exotic matter to bend spacetime. Lentz's solution also improved energy distribution around the warp bubble, making the geometry far more practical. Still, the Lentz warp drive remains purely theoretical. His next goal is to design a warp bubble capable of moving at 1% of light speed using a modern fission reactor. He's even considering patenting his design, but emphasizes that his work is only one part of a fast-growing field. Since Alcubierre's original paper in 1994, the progress in warp drive theory has been astonishing. Many believe that a real, testable version may be closer than we think. As Dr. Lentz himself said, it's exciting to see how far the field has come and how much more we might achieve in the coming years. Now tell me, do you think humanity will ever travel at the speed of light within our lifetime? Leave your thoughts in the comments and I'll see you in the next video.